When an agent runs long enough, it starts to accumulate stuff, and all of that has to live somewhere. And if you are building agents that needs to persist across sessions, or agents that other people need to trust on, then somewhere can't just be an answer. You need storage where the history can be verified, storage where nobody can quietly edit what happened, storage where you can prove the data is actually being held. The Filecoin Onchain cloud gives you exactly this, a way to organize this kind of AI agent data. And once you understand how datasets and metadata work, you will see how to build agent memory that's both queryable and verifiable. A dataset is basically a container. You upload files to FOC. Each file becomes what's called a piece, and piece live inside dataset. All the pieces in dataset get stored and proofed by the same storage provider, which means they share payment arrangements and proof obligations. For agents, this is useful because you can delegate a dataset to one agent or one session, or maybe one category of output. Everything stays organized. When you want to check on the storage health or manage cost, you are dealing with logical groupings that map to how you actually think about your agent's data. The Synapse SDK makes this pretty flexible. When you create a storage context, the SDK can handle provider selection, and the dataset creation would just happen automatically. Or you can be explicit about it. Pass in a specific provider ID, attach metadata to the dataset, and actually control where the things land. This choice depends upon how much you want to control as per your needs. Now, metadata is where things get interesting for agents memory, because metadata is what makes your stored data searchable. Both datasets and individual pieces can carry key value pairs that you define at upload time. For a dataset, you might tag it with a agent ID or session identifier. For individual pieces, you will have to include timestamps, event types, task references, whatever context you need to give to make things make sense. The time limits, or the limits that are enforced by blockchain contracts, they are around, data set can get up to 10 key value pairs, pieces gets up to like 5, and like keys can be like around 32 characters, which values up to like 128. So the SDK checks all of these before the submission and gives you more clear errors if you exceed any of it. So this means you can structure your agent storage so it's actually useful to query. And you can upload a log entry and tag it with a type. That can be just a log and a timestamp. Upload a state snapshot and tag it with the task that triggered it. Later, when you need to figure out what actually happened, you list the pieces in your dataset, filter by the metadata you attached, and reconstruct the timeline. Every piece you With every piece, like, you actually get a PCID when you upload it. This is Filecoin's content addressed identifier. It's computed directly from your data, so like we have mentioned, even if you change a single byte, everything changes. So you get a completely different identifier if anything of the data changes. So that's the integrity is actually built in the address itself. For agent history, this really matters. Every piece of your memory your agent stores has a unique identifier that proves the content is authentic. The metadata tells you what it is, the PCID proves that it hasn't been tampered with. Perfect, right? So this is because like everything lives on Filecoin Onchain Cloud. And the storage providers are continuously running proofs to demonstrate that you still have your data. Now, when you need to get the data back, you download using PCID. Again, any provider that has the piece can serve it to you. If you enable a CDN, when you set up your storage context, that's with CDN option, retrieval goes through Filecoin BIM with cache the data and storage providers for faster like global delivery. Either way, you are pulling from the storage provider where the real economic incentives are provided to them to keep your data available. For querying what's in the dataset, the SDK gives you methods to list down the pieces and get their metadata. You can walk through everything your agent has stored, filter by the tags you have applied, and build up whatever view you need. So that's the creativity that a developer can show. So it's not a full database, you are not writing SQL, but for the kind of retrieval agent memory typically requires, it would handle the job. A pattern that works well is like treat each significant agent action as its own pieces with a consistent metadata. Log entries can get the type as log and timestamp. So the state snapshot would get something like type as state and reference to what triggered them. And maybe another one like tool output can get type as tool plus whatever context like links do you wanna add back to it. When something goes wrong, you need to debug, or when someone needs to audit what the agent did, you can just list them the pieces, filter by type, sort by time. You have got a complete reconstruction. The storage is decentralized, the contract is verified, and the history can't be silently rewritten. So that's exactly what we have, like, dreamed of a decentralized AI agents economy. One more thing that's like very worth to understand is like how the cost works. The Filecoin on-chain cloud uses pay per epoch model, where each epoch time is like 30 seconds. You deposit USDFC tokens, the stable coin on Filecoin, and then set allowances that control how much the warm storage service can spend on. So this service requires a 30-day prepayment buffer. So if your balance drops below that, the provider can remove your data. For agents that accumulate memory over time, you'll want to estimate how much data they are generating, and you can budget it accordingly. So lots of small uploads adds up differently than occasional larger ones. So the documentation has calculators to help you figure out the right size of the deposit. What you end up with is a storage layer where agent memory is content address verifiable backed by cryptographic proof instead of trust. Your agent's history lives on infrastructure that doesn't depend on any single company staying online or just keeping promises. Anyone who needs to verify what happened can actually examine the proofs and identify themselves. Dataset gives you organization, metadata gives you queryability, PCIDs gives you integrity, and proof of data possession gives you ongoing verification. That's the perfect foundation of your agent memory that will outlast whatever database you would otherwise be backing up with. So that was all about like how you can have like FOC to elevate the experience of your AI agents and have the entire identity of AI on chain.